Hey, what's going on, guys? This is my another video about complex numbers. In my previous video I have made complex number series, but that's a whole different thing. Here we are going to do the different thing. Like here we are going to see rectangular and polar form as well. If you don't know what I made before, you can go ahead and check my channel. It's already there, but this is a different series where it's about complex number in a rectangular form and for polar form. We are going to see the differences, and we are going to see many examples on that differences and factoring out, multiplying, adding, and all these things. Now let's look at this. Is my first video. I'm going to make it a series as well. This is my first video on that. Now let's look at what is complex number first. Complex numbers always come with real number and imaginary number. Okay. I have some, it's loading here. I'm waiting for it to respond. Okay, now it's okay, I guess. Okay, let's go. Okay, let's go. The imaginary number always come with the real number and imaginary number. A is a real number and bi, whatever the number that comes with I, is an imaginary number. Now for example, let's see how we can locate this one in a graph. For example, let's say this is our graph and we have some points on it. Like let's put some 3, something like that. Okay, let's create an equation. First let's say we have a complex number like this. Z is equal to 2 plus 3i. This is our complex number, and here real number is 2, 3i is the imaginary number, and real number always take the x-axis, so 2 is going to be here. This is our x-axis, 2 here, and 3i is here. Imaginary number is y-axis, real, imaginary. So the location of the number is going to be 2 in the x-axis and 3 in the y-axis, so it's going to be right here. Now let's look at another example. Let's say we have a complex number that's given like this. Z is equal to minus 3 minus 5i. Minus 3 means it's going to be somewhere here, 1, 2, 3 here, and minus 5i mean here bottom, 1, 2, 3, 4, 5. So 3, 5, the location of the complex number is going to be exactly here. This is the A here, and this one is B, is here. Now let's look at another one. Let's say we have a complex number given like this. Z is equal to negative 4. Negative 4 mean it's gonna be in the x-axis, and here if they just give negative 4, it means the real number is negative 4, but the imaginary number doesn't exist. It means 0. So it's only x-axis. So it's gonna be somewhere here, right? Now let's say that we have a number given like this. C is equal to 0 plus 2i. It means we only have the imaginary number. That's gonna be just y-axis. So the 2 is gonna be right here. That's how we can locate complex numbers in a graph. Okay, now let's see how to find out the absolute value of a complex number. I'm going to erase all these things. I'm waiting for it to respond. Okay. Now here we are going to see how to find out the absolute value of complex number. Absolute value of a plus bi. A plus bi is a complex number. And to find out the absolute value, we use this equation, square root of a square plus b square. Now let's look at an example. Let's look at it in a graph. And here we know that b is the imaginary number, so it's going to be in the y-axis, and a is the real number, so it's going to be in the x-axis, and the hypotenuse of that one is the absolute value. So this is C. That's why we have Pythagorean theorem, a square plus b square. Now let's look at an example. Let's say we have z is equal to 4 plus 3i. Here a is 4, b is 3, so we just have to therefore the absolute value of this one is going to be, I get rid of this one, absolute value of this one is going to be just simply a square plus b square. In our case a square is 4 square, b is 3 square, 4 square is 16, b square is 9, so 16 plus 9 25, therefore the answer is 5. That's how we find out the absolute value of complex number. Now let's look at some more example. Let's say we have z is equal to 4 minus 6i, and here we know that a is 4, so 4 square, and b is negative 6 square, 4 square is 16, negative 6 square is 36, 16 plus 36 is equal to 52. Now we have to see what's the highest square multiplication. Like square numbers are 1, 4 and 9, 25. The multiple, like 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, like that. We have to see which is the highest multiplication that can bring 52. The highest multiplication is 4. We cannot have any multiplication above 4, so 4 times 13 is the highest multiplication of square. So 4 square root of 4 is, so we can also write it as square root of 4 times square root of 13, and square root of 4 is simply 2. My mouse, I'm waiting for the mouse to respond. Okay, square root of 4 is 2, so 2 square root of 13 is the final answer. Now let's look one more example. Let's get rid of this, and I'm gonna write with a different color. Let's say we have an example. Let's say we have a question like z complex number is equal to negative 1 plus 7i. What is the absolute value? Again, square root of a square plus b square. A is negative 1 square, and b is 7, so 7 square. Negative 1 square is 1, 7 square is 49, and we get 50. And now we have to see what is the highest square number multiplication of 50. 25 times 2. 25 is the highest number. We cannot go anything above 25 square number. So 25 times 2 is 50. So, and also square root of 25 is 5. So 5 root 2 is the final answer. And that's how we find out the absolute value of a complex number. Now the final thing we are going to see is rectangular form and polar form. What's the difference between rectangular form and polar form? Complex number in a rectangular form will be written like this: z is equal to a plus bi. But in polar form it will be written like z is equal to r times cosine theta I plus I sin theta, cosine theta plus I sin theta, not I here, cosine theta plus I sin theta. This is rectangular form, and this one is polar form. And if you graph it in a rectangular form, the graph of the rectangular form will be look like this. Here in a rectangular form, a is the x-axis, and b is the y-axis. B is the imaginary number, that's y-axis, as we've seen before. And then the absolute value is z, that's hypotenuse. Now how does it look for polar form? In polar form is a similar thing. Again we are going to have a is the x-axis, a is the x-axis, and b is the y-axis. and the hypotenuse is going to be the absolute value. Now there's an equation to find out the hypotenuse in a polar form, that is absolute value of c. That one is equal to, again we seen before, a square plus b square. And also we can calculate the angle of the angle that making the rectangle, the angle of the hypotenuse, that can be calculated using tan -1 b over a. And that's it. I'm gonna do examples on this in my next video. I hope you guys find this video helpful. Thanks for watching. See you guys on my next video.